So good morning. Okay, so good evening to all of you. Today we are going to discuss about week 4 lecture. It is about the introductory organic chemistry part 1. It is an NPTEL platform course which is running on NPTEL platform, and the course instructors are Professor Harinath Chakrapani, Professor Neeraja Dashaputre from ISER Pune, and I am your AMRF teaching assistant Simran. So I hope all of you have gone through my previous videos, and if you have any doubt, I will love to answer that question. So if you have any doubt, please ask me right now so that we can begin with the today's lecture. So anyone has any doubt? Okay. Okay, if no one has any doubt, then I will proceed for today's lecture. So it is about week 4, and the topic is acidity and basicity. In this lecture, we will see the problems containing acidity and basicity of organic compounds, how you can identify the acidity and basicity in basic organic compounds. So, this is dedicated to that part only. So, I'm starting from problem number 1. So, this problem number 1 is actually asking which one of the following is the strongest acid. So, you have to answer that which one is strongest acid in these four. So, before answering these things, first of all, you need to know that the counterpart which is connected with this acidic part is chlorine atom. Is chlorine atom, right? So, what happens? Chlorine atom, as I have told you earlier, is an electronegative atom. So, the number of chlorine atom which is attached to the carboxylic group containing carbon will increase the acidity of that particular carbon. How now? See, the electronegativity of halogen is decreasing when we are going down in the group. So, coming to the chlorine, which is a very electronegative atom. So, what happens when you have this Cl COH bond, right? Cl basically connected with a carbon, which is another way connected to this carboxylic acid, right? So this is CH2, and which in turn is connected to this carboxylic acid group. So I am drawing it like this. So here there is another OH. Fine for everyone. So here now, see, this chlorine atom being electronegative, it will push the electron towards itself. So this is how you will see that chlorine will push the electron density towards itself. So now when pushing the electron density towards itself, it is making this carbonyl carbon more electropositive in nature. Right? How? Because when it is pulling the electron density from this carbon, it is in turn pulling the electron density from this carbon of carbonyl group. So it is making it more electropositive in nature. So if the carbon is electropositive, then what happens? Then this OH bond will get polarized, will get more polar. Why? Because now the carbon will abstract electron density from this oxygen, the adjacent oxygen. So here carbon will push electron towards itself by the oxygen because of the electropositive nature now it is encountering. So the OH group will become more polar. So this is more polar group. So here, if the OH bond is getting polar, that means it will release this H plus very quickly because now the OH bond is weak. So when it is weak, the H plus is readily, like it will leave very readily. So coming back to the question, so they are giving you the option in which chlorine atom is 3, 2, 1 or 0. So this acetic acid group doesn't contain any chlorine atom at all. So it would be least strong acid because here the electropositivity is not that much, which in the case of these three, because of the presence of the chlorine atom that is electronegative, the electropositivity of the carbonyl carbon is getting increased. So that is why the number of chlorine atom will decide the electropositivity of the carbonyl carbon. So if the electropositivity is high, then your OH bond is more polar. So if the OH bond is more polar, it will give you the H plus very readily. So that means it is behaving as a stronger acid. So here comes the role of electronegativity of the chlorine atom. So increase the number of chlorine atom and the increase in acidity will be observed because of the electronegativity behavior of chlorine. So amongst these four, the D option, that is CCl3COH, will be the highest strongest acid. Okay, it will be strongest acid. Why? Because of the electronegative behavior of chlorine. It will push the electron towards itself, making the carbonyl carbon more electropositive and the OH bond more polar in nature. So that is why OH bond is now weaker and H plus is readily available. So here option D will be the correct answer. Okay, so is it understood to everyone? I hope it is clear to everyone. If you have any doubt, please ask me right now. Okay, no one has any doubt. So shall I proceed for problem number two? See, I am giving you 10 seconds so that you can go through the answer which I have given to you guys. So please make sure that you have got the answer. Otherwise, please ask me if anything is not clear. Okay. So it seems like you don't have any question regarding this problem. So I am going to problem number two. Now, in the problem number two, they are saying arrange these acids in order of increasing strength. So now you have to arrange these acid A, B, C according to the increasing strength. They have given you the pKa value for that. Each acid you have given the pKa value. So in the next, they are also asking, given the solution of same concentration, which would have the highest percent ionization. So now we will answer first the acidity order and then we will go through the highest percent of ionization, which acid will possess highest percent of ionization. So coming back to this first problem, here they are asking arrange these acid in order of increasing strength. So pK is given. So now pKa has a relation between your with your Ka. Ka is what? It is a dissociation constant. So now acid has a particular value for the dissociation constant. That is the dissociation it will show in any solvent, or ionization it will show in any solvent. That would be the dissociation constant. That is denoted as Ka. Fine. So if Ka has a relation with pKa, so what was it? Here, as you can see, pKa value has a relationship between your dissociation constant. So with your dissociation constant, it shares minus log of Ka. So here, as soon as your pKa value is going high, the Ka value will go down, right? As you can see this, the relation between pKa and Ka is minus log of Ka. You can say if pKa value is getting higher, then your Ka value is essentially getting low. So what happens? What does it mean? If pK is higher, Ka is low, what happens? So now, if pK is higher and Ka is low, as I have told you, Ka is nothing but dissociation constant of an acid. So acid dissociation is less if the pK value is high. What that means? It means like acid is not stronger enough to get highly dissociated in the solution. That means if a acid has a high pKa value, then the Ka will be lower, which means the dissociation constant is lower, which means the acid is not strong enough. So that acid will behave like a weak acid. It will not dissociate that much in the solution. So that is why we are saying it has an inverse relationship. So what do you mean by inverse relationship? If the stronger the acid, the higher the value of K and the lower the value of pKa. That is what you need to know. That pKa will decrease, Ka will increase. If pKa decreases, Ka decreases if pK increases. So for strong acid, Ka is high, but pKa is low. But for weak acid, pKa is high and Ka is low. So is it clear to all of you this much? Because you need to know the relationship between these two so that you can answer this particular problem. So here Ka and pKa are inversely related with each other. Okay. So is it understood? Is it understood, everyone? Okay, fine. So if it is understood, then tell me which would be the highest increasing strength of acid, which should be the more strong acid. Here acid A has a pK 1.52, B has a pK of 6.93, and C has a pK of 3.86. So highest value of pK is shown by acid B, that is 6.93, right? So if highest value of pK is acid B, then it has a lowest value of K. Is it right? Yeah. So here it will have a low value of Ka. Clear? So Ka value will be lowest for this particular acid B. So Ka value will be lowest. So what that means? It means that acid A, when you compare acid A and B, the pK value of acid B is higher, Ka is lesser, and pK value for acid A is lower than pKb. That means acid A is stronger acid than acid B, right? Because Ka for the acid A is higher than acid B. So if you are comparing these two, then you can surely say that acid A is higher in strength than acid B. So when you are comparing this acid B with acid C, what happens? Then you can say this acid C is stronger than acid B, right? So if acid C is stronger than acid B, why? Because here pK value is lower than the pK value of acid B. So if you are comparing these three, what can you say? That acid A will be of higher strength, will be of higher strength than acid C, then acid B, acid B. So this will be the increasing order of acidity character of these acids. So B has a lowest acidity uh, by C, and which in turn is weaker acid than A. Fine. Is this clear to all of you? This particular sequence. So now coming to the next part, that is which would have the highest percent ionization. So as I have told you, Ka is denoting the dissociation constant. So percent ionization is directly related to Ka, because when in the solution you will dissolve an acid, the ionization will surely depend upon the dissociation constant. So higher the dissociation constant value, higher will be the ionization. So if a acid has a higher dissociation, what that means? It means that it is a stronger acid. So the strongest acid is the acid A. So that means it would have a highest percent of ionization. Highest percent of ionization because of higher Ka. Because of higher Ka. So Ka is directly related to percent ionization. That is why we are saying if the acid A is the highest acidity acid, then it would surely have the highest percent of ionization, right? So this would be acid A, which is having the highest percent of ionization. And the correct order of sequence is B, C, and A. Is it clear to all of you? Any doubts, any query regarding this problem? Anything you want to ask? Okay, if not, then coming to problem number 3. So problem number 3, they are asking which of the following pairs does not show an acid and its conjugate base. So for answering these kind of question, you first need to know what is acid and what is its conjugate base. So for having that idea, I am introducing you to a term that is a conjugate base of a acid. What it is? It is like the compound which is remaining after a hydrogen ion is donated by the acid. See, if you have an acid, let's say H2SO4, so sulfuric acid is there. So what is the conjugate base for that acid? After the donation of the hydrogen ion, the species which is left is the conjugate base of that particular acid. So after removing one of the proton from H2SO4, what happens? What did you get? It is HSO4 minus. So if it is HSO4 minus, then you can say that HSO4 minus is the conjugate base of H2SO4. So conjugate base of acid is the compound which is remaining after a hydrogen ion is donated by the acid. So if acid is donating a hydrogen ion, then the remaining compound will be what? Conjugate base of that acid, right? Similar, on the same line, we can also say the conjugate acid of a base. So base, let's say we are taking ammonia. So NH3 is a base, right? So now the conjugate acid you have to find for that base. So it is opposite, right? So here the conjugate acid for the base is the compound which is remaining after the acceptance of one hydrogen ion. So after accepting one hydrogen ion, what happened to NH3? It will go to NH4 plus. So if it is NH4 plus, then you can say that it is a conjugate acid for that base. So NH4 plus will be the conjugate acid of NH3 base. Is it clear? So this is the concept behind the conjugate base of an acid and conjugate acid of a base. So conjugate base of an acid is the compound which is remaining after a hydrogen ion is getting donated by the acid. But the conjugate acid of the base is the compound which is remaining after the addition of proton in the base. Fine. So this is what it means. So now coming back to the question, here they are asking which of the following pair does not show an acid and its conjugate base. So if it is not showing acid and its conjugate base, what will be the correct answer? See here, coming to option number A, nitric acid and NO3 minus. So I have told you that acid is nitric acid. The conjugate base is getting created after the release of one proton, one hydrogen ion. So after releasing one hydrogen ion, what will be lefting? It would be left with NO3 minus. So that is why we are saying that it is a correct answer, because nitric acid is an acid and NO3 minus is a conjugate base of that acid, right? So here option number A is correct. So now coming to option number B. I've told you H2SO4, sulfuric acid and HSO4 minus. So sulfuric acid is an acid and we have to find the conjugate base for that acid. So what happens after removal of one proton, you will see what is lefting behind. So it is HSO4 minus only which would left behind. So here the correct sequence is there, because acid is H2SO4 and the conjugate base is HSO4 minus, right? So option B is also correct. Coming to option number D. Now coming to option number D, HSO4 minus and SO42 minus. So here, if you see, HSO4 minus will behave an acid, but after removal of one proton, what you will get is SO42 minus again. So here, this option is also correct, because after removal of one proton, you are getting the same species which is written here, that is SO42 minus. But when you come to option number C, now coming to the option number C. See here what happens. H2SO4 is an acid, but they have mentioned as a conjugate base SO42 minus. Is it right? No, because the conjugate base is a species which is formed after removal of one proton of the particular acid. One hydrogen loss of an acid is generating the conjugate base. So that is why we are saying here SO42 minus will generate after two proton is getting lost, which is not the definition of conjugate base. So here we can say the option C is not matching with a conjugate with the acid and its conjugate base definition. So here correct option will be option number C, because it is not showing an acid and its conjugate base pair. Fine. So is it clear to all of you? Any doubts, any query regarding this, please ask me right now. Okay, if not, then we will proceed further. Coming to problem number 4. So here they are asking which compound is most basic. See, most basic compound you have to find out. So finding out the most basicity in a compound, what will you see? Here nitrogen has lone pair in all the cases, right? So if you have to find which compound is most basic, so basicity depends on how readily the nitrogen lone pair is donated to other species. So you have to see how readily this nitrogen lone pair is available for other species for a electrophile to attack. So this is how you have to see. So coming one by one to all the four things. So here, if you come to the option number A, what happens here? the lone pair of nitrogen is readily available for the electrophile. Why? Because it is not present in any conjugation, any other thing. So it is readily available on the nitrogen atom. So when you are coming to option number B, what happens? The CF3 group is connected at this fourth position. So this CF3 is nothing but an electron withdrawing group. So if it is an electron withdrawing group, what happens? It will push the electron towards itself. It will push the electron towards itself. So it is making this nitrogen center less basic because it will pull the electron density from this side as well. So nitrogen lone pair is not remaining that much basic. That is present in option number A. Now coming to option number C, where the scenario is also very much different. So in option number C, what is happening? The lone pair which is present in the nitrogen atom is now in the conjugation. Is showing conjugation. Is showing like this. It is delocalized. So because of this delocalization with the aromatic ring of this nitrogen lone pair, it is not available, not that much available for the electrophile that is present in option number A or B. Because here only minus I effect of this CF3 is taking place, but the NH2 is not delocalized with this particular cyclohexyl ring. But here, due to the resonance effect, due to the delocalization with the aromatic ring, this nitrogen lone pair is not available electrophile for the electrophile, which in turn is available in the case of A, that is cyclohexylamine. Now coming to option number D. So methyl, it is present at the para position of this aniline. So now here it is an electron releasing group. So it is a electron releasing group. So it will release electron towards this aromatic ring, and which in turn make this nitrogen more basic than this aniline. So if you have to compare between these two, which is more basic, which is more basic? Yes, option number D will be more basic. Why? Because here methyl group is behaving as a electron releasing group. So it will donate electrons towards this aromatic ring, and which in turn is making this NH2 more basic and more available for the electrophile. But in the case of C, the nitrogen lone pair is delocalized, and that is why it is not readily available for electrophile. But when you are considering these two, then what? Which is most basic? Then you can quickly say that A, cyclohexylamine, is more basic than this B. Why? Because CF3 is electron withdrawing group and it is withdrawing the electron towards itself. So now we have two species in hand, this A and this D. There are two species in hand, this A and D. So if you have to compare A and D, which is most basic? Anyone? Which is most basic? Can anyone tell me? Okay. So between this A and D, which is more basic, the cyclohexylamine is more basic. Why? Because here there is no delocalization, neither any minus plus I effect which is present in this particular compound. So the lone pair of this nitrogen is very much available for electrophile. But here, instead of having an electron releasing group attached at para position, the nitrogen lone pair is still in conjugation, right? So it is not that much available for the electrophile which is present in A. So A will be the most basic species in the in all the four compounds. So the correct answer will be A. Cyclohexylamines are most basic than aniline. So here amines are the most common organic bases, and alkylamines are usually more basic than aniline ring, whose basicity may be modified by substituent in the benzene ring. So here also we are considering this postulate. So here also cyclohexylamine is more basic than aniline. Okay. So everyone understood this particular answer, particular problem is clear to all of you. So if it is clear, then I'm moving towards the problem number 5, right? So now in the problem number 5, they are asking which substituted benzoic acid is most acidic. Now you have to answer which substituted benzoic acid will be the most acidic acid. So here, if you see all the four benzoic acid, so we are encountering one by one each benzoic acid, so to judge the acidity. Okay. So here, if you see in the case of one, this benzoic acid, the chlorine is attached at the meta position. So what happens? Now this chlorine, as I have told you, is electronegative atom. If it is electron negative atom, it will withdraw electron towards itself. It will withdraw electrons. So it is withdrawing electrons and making this carboxylic acid carbon more electropositive, because now it is withdrawing electrons towards itself, and this carboxylic group carbon is more electropositive. So when you are coming to option number B, similar cases here. Also Cl is attached at the para position. Just the meta and para substitutions are there. But when you are coming to C, methyl group is attached at the meta position and methylase group is attached at the para position. So now tell me, for the acidity, see guys, it is different from the basicity. So if you are seeing that, if you are thinking that a compound is basic, then it should have electron density with it. Okay, with it, it should have the electron density with it. But when you are considering the acidity, the carbon or the particular compound should be electropositive enough, because only then it will be acting as acid. If the carbon if this carbonyl carbon is electropositive, then only this OH is polarized, and this OH, if polarized, will release the H plus very readily. So here, if OH group is polarized, only then it will behave as a good acid, right? So we have to see in all the cases which species is making this carbonyl carbon more electropositive. So this is the real funda which you have to look in all the cases. If you have to see the acidity, you need to think about the substituent which will make the carbonyl carbon more electropositive. But when you are saying about the basicity, the reverse is true. So now you have to see which species, which substituent is making your particular carbon of interest or nitrogen, oxygen of interest, whatever, more basic, more electron density, which is giving towards it. Okay, so this is a basic funda. So now coming back to the question here, C, if you are seeing C and D, the methyl is electron releasing. It will release the electron towards the aromatic ring. So it will making this carboxyl group now less electropositive than in the case of A and B. Is it true? Yeah. So in the case of C and D, the carbonyl carbon of the carboxylic acid is not that much electropositive when you are comparing it with A and B. So these two options are getting neglected now because of the presence of electron releasing group at the or metapara position of this carboxylic acid, benzoic acid, which is making this carbonyl carbon less electropositive than these two. So now these two you have to compare which is most acidic. So two options are getting eliminated. So here you have to worry about A and B now. So here in A the Cl is present at the meta position, but in B Cl is present at the para position. So now you have studied one thing, that inductive effect will decrease is actually dependent on the distance between the substituents. So now if inductive effect is operative in this case of chlorine, then it will surely depend upon the distance. So now when you are saying the distance of this carboxylic acid and this chlorine is 1, 2 and 3 carbon away. But here if you are comparing B, then it is 4 carbon away. So inductive effect is decreasing with increase in the distance. So the effect of inductive minus I effect will decrease with the increasing of the distance. So here you have to apply the similar concept, and you have to see that here meta position Cl actually is actually behaving more like minus effect is more operative there as in the case of para position, Rather, in the para position, resistance is higher, so the inductive effect is lower. So, chlorine and the option A will will show a high inductive effect, and because of that, what happens, this carboxylic group, carbonyl carbon, is now electropositive enough than B. And here, if the electropositivity is there on in the carbon, what happens, as I've told you, this OH bond will become more labile, and if this become more polar, then H plus is readily available. So here the correct option will be option number A, because benzoic acid is, which is most acidic, is the chlorine with the meta at the meta position, not at the para position, because inductive effect will be depending on the distance. It is distance dependent. So that is why if the distance between the substrate increase, the inductive effect will decrease. So here the option number A will be the correct one. So is it clear to all of you? Any doubts, any queries regarding this thing? Okay, so if not, we will proceed to problem number 6. So in the problem number 6, they are asking which of A to D shows the increasing order of acidity of phenol 1 to 4. So now you have to show which is showing, you have to decide which is showing highest acidity of alcohol. You have to order them from increasing order of acidity. Increasing order of acidity. So now what happens? See, if you have to see that which is more acidic in alcohol, so now you have to see what is actually connected at the adjacent end of the carbon. So now just tell me which would be the higher electronegative species. The species, the carbon which is sp hybridized, the carbon which is sp2 hybridized, carbon with sp3 hybridization. Anyone? sp2, sp3, sp, which is more electronegative carbon. Okay, to cut the story in the short, the sp carbon is highly electronegative than sp2 carbon, which in turn is highly electronegative than sp3 carbon, right? Why? Because as you are increasing the s character in the particular bond, what happens? Your electronegativity is getting increased. So s character in sp is higher than s character in sp2, then which is in order higher than s character in sp3. So that is why if compound 4 is having sp, s and p, sp hybridization carbon near it, then it will be behaving as more electronegative. So here after removal of the proton, what happens? This oxyanion is getting formed. In each case, this oxyanion is getting formed after removal of one proton. So you have to see which carbon is stabilizing this al- oxyanion more. So you have to see that only. So here in the case of 4, the carbon is sp hybridized, and thus it is stabilizing this oxyanion very much than sp2 and sp3. But when you are comparing this 2 and 3, what happened? Now when you are comparing this 2 and 3, both of the oxyanion is now adjacent to sp2 hybridization carbon, right? But what happened? 3 will be facing another stabilization via delocalization. Now this oxyanion is now in delocalization with this double bond with this sp2 carbon. So which is providing an additional stability to this oxyanion. So the acidity of this third alcohol will be higher than 2. Why? Because of the for another stabilization by the delocalization. Rather, two of them is connected with the sp2 carbon, is electronegative enough. ठीक है, लेकिन but the thing is, the oxyanion which is getting formed in the 3 is further stabilized by the delocalization. So there is another factor which is stabilizing this oxyanion in the case of 3. But in the case of second, what happens? The oxyanion is only stabilized via sp2 carbon. But when you are seeing one, here, only sp3 carbon is present for the stabilization. So I have told you Sp is more electronegative than sp2, which is more electronegative than sp3. So sp3 will stabilize this oxyanion very less than sp2, which stabilize less than sp3, right? But here, due to the presence of this delocalization in the third alcohol, it is making that particular species more acidic even than of the 4. Why? Because here, see, 4 is connected to sp carbon, right? Fair enough, but it is not in the delocalization with this sp carbon. But here this 3 is connected with sp2, but an additional factor is there of delocalization, which is giving more stabilization to this oxyanion, which is getting formed after the deprotonation of this alcohol. So that is why we are saying 3 is more acidic than 4, which in turn is more acidic than second, and which in turn is more acidic than 1. So the least acidic species will be 1, the most acidic species will be 3. So the correct order will be what? So now the correct option will be option number B. Why? Because 3 has another stabilization, which is because of the delocalization. So now you have to think about that also. So here, instead of sp2, sp3, one another factor which is governing here is a delocalization. So that is why 3, which should be less acidic than 4, but is more because of the delocalization. So here 3 is highest in acidity, then 4, then 2, and then 1. So this will be the correct answer. Right. So is it understood to all of you? Any doubts, any queries, guys? Okay, so if not, then I'm moving to problem number 7. So in the problem number 7, what they are asking, which of A to D again shows the increasing order of basicity. So we are talking about the acidity in the previous case, but now we are talking about basicity of the compounds 1 to 4. So one by one we will see what is more basic. So here in the case of 1, this nitrogen lone pair is in readily available is readily available and not in any conjugation, right? So here, when you are coming to option number 2, this is not a free amine, it is actually a imine bond. So here, imine bond basicity is very low than amine, because there is no lone pair of nitrogen which is present for the for attacking any electrophile. The nitrogen lone pair is not present in the case of imine. So second option is not a amine in which the lone pair is present on the nitrogen. So here it will be the least acidic because of the presence of this imine bond. Imine bond is way less basic than amine bond, right? So now coming to option number 3, here also see, one bond is imine bond, and one is amine. So here this amine nitrogen lone pair is in conjugation with this imine carbon. So after the delocalization, now just tell me what is happening. See here, after delocalization, this negative charge is getting generated on this nitrogen, and here also the delocalization is there. Similarly, a negative charge is generating on the nitrogen. See this. This is also the case. So here, if the negative charge is generated on the nitrogen, so I have to tell you one thing, that lone pair basicity is less than an ion. So anion donation ability is higher than the lone pair. So that is why a species which is getting generated in the case of 3, that is a negative charge, has the higher donation ability. So just tell me which would be the highest basic compound. Any guesses? Anyone? It would be 4. Why? Because there is two lone pair of nitrogen that are directly available for the attack of electrophile, but also after delocalization, in both ways the delocalization can occur, right? Here also this can delocalize. So if after delocalization the species which is getting formed is now the amide, so NH minus is getting generated, guys. So now the donation ability of lone pair is also getting enhanced. So that is why this 4 is way more basic than 3, which is more basic than 1. which is more basic than 2, because I've told you imine bond is way less basic than amine bond, right? So that is why we have an order that 4 is having the highest basicity, then 3, which in turn has highest basicity than 1, which is in higher basicity than 2. So the correct option which is matching with the sequence is 4, 3, 1, and 2. The option number C. So option number C is matching with this 4, 3, 1, and 2. So that is why the correct option will be option number C, because now in the case of 4, there are two lone pair of nitrogen which is free for the electrophile trapping, and also after delocalization a negative charge is getting generated on nitrogen, and the negative charge donation ability is higher than the lone pair. So in the case of 3, one free amine is there, and also after delocalization a amide bond is getting generated, that is also uh, donating. So in the case of 1, lone pairs exactly are in the donating form. But in case of 2, imine, there is a way less basic than amine, because there is no lone pair of nitrogen which is present for a direct attack, right? So the correct option will be C. So anyone has any query regarding this problem, regarding the answer, or you are not you're not getting the concept of basicity? Anything? Any query? Okay, so if not, then I am going to problem number 8. See, here also the explanation is same. So they are explaining in the terms of sentences. So you can give it a read, so that you can get how these things are basic enough. Okay. So now in the problem number 8, arrange the following in the order of increasing acidity. So they are asking arrange the following in order of the increasing acidity. So you have to arrange it from the least acidic to most acidic. So now can anyone tell me that which of the species among these five is highest acidity species? Okay. So guys, what happens here? The species 4 and 2. As you can see, some of the people will say that the carboxylic acid is there, so which means the highest acid is going to the carboxylic acid. The fourth option is correct, but here you have to keep in mind one concept also, that is electronegativity. So I'm keep repeating this electronegativity concept. It is very useful when you are talking about acidity, basicity, or something. It is very useful, so give it a thought that here oxygen is also present with a positive charge. So now, as we have seen, oxygen is an electronegative atom. So now oxygen will stabilize this oxy anion more. The negative charge is stabilized on the electronegative oxygen, but a positive charge is not stabilized on oxygen. So oxygen wants to get rid of that positive charge as soon as possible. As soon as as soon as it gets a chance to release this positive charge, it will do that for very fast. So here, in the second case, oxygen is having a positive charge. So as soon as it gets a particular charge released, it will be stabilized. So now second is highly destabilized species. So now after removal of this one proton, it will get it will get a neutral charge. So here this OH2 is acting as a higher acidic form. Why? Because it wants to release H plus as soon as it gets a chance. So here H plus removal, H plus H plus donation is very much facile than carboxylic acid. So if you are comparing this 2 and 4, here OH2, because oxygen is a electronegative atom, positive charge is not stabilized on oxygen. It wants to neutralize the charge. That is why H plus is readily removed from this particular species. So here second would be the highest increasing acidity species. So here second is the acidic species, most acidic species. Okay. Now coming to the second most acidic species. So So if you are talking about second most acidic species, it will be 4. Why? Because it is a carboxylic acid. And we know carboxylic acid will release H plus very readily in the system. Now, if you have to compare this 1 and 5, just tell me which will be more acidic, 1 or 5. See, acidity order you have to decide after the removal of one proton, it will get an oxygen ion. So now, which oxygen ion is most stabilized will be the highest in acidity, because the tendency to lose proton will be higher for that species where oxygen ion is getting stabilized. So when you are comparing 1 and 5, so here this oxygen ion is highly stabilized due to the resonance with this ring. So it is highly stabilized. But if you are talking about ethanol, there is no resonance stabilization in this ethanol. So that is why what happens, one will become more acidic than 5, right? So one here is more acidic than 5. So here the correct order will be 2, 4, 1, 5, and remaining one is 3. Here this ether is present. So here after removal of one proton, what happens? This carbon gets a negative charge. In all the cases your oxygen is getting a negative charge, but here the carbon is getting a negative charge, which is not that much stabilized than the negative charge on oxygen because of the electronegativity of the oxygen. So that is why third will be the least acidic species in the system. So the correct order will be second, fourth, one, fifth, and then the last one is 3. So the correct option which matches this sequence is option number D, because second is the highest acidity systems, second is fourth, third one is 1, and the fourth one is fifth one is third. So here this will be the correct order of the sequence of acidity. So is it understood, all of you? Any doubts, any queries regarding this problem? Okay, so if not, then I'm moving towards this problem number 9. So in the problem number 9, they are asking the amino acid glycine has two acidic hydrogens, one with a pKa of 2.34, one with pKa 9.6. What structure of glycine predominate at a pH of 12? So now you have to answer a critical question, that what form of the glycine will be predominated at the pH of 12? So as you know, the pH of 12 means the basic medium. So now one by one we will go through this question. So glycine, this is the form of glycine. So here it has two acidic protons. So now tell me which one will be the acidic proton. This carboxylic acid proton is acidic, and also the proton which is present at this carbon, alpha 2 carbonyl, is acidic. NH2 proton is not acidic, right? So here two acidic protons are present in glycine. That is, one is the carboxylic acid proton, second is the proton which is connected to the alpha carbon of the carbonyl carbon, right? Alpha carbon to the carbonyl will contain second acidic proton. Is it clear, everyone? This much? Okay, if it is clear, then we will move towards the pKa value. Now, one will be having a pKa of 2.34, but another one will be having a pKa of 9.6. I have told you, higher the pKa value, lower the Ka. Higher the pKa, lower the dissociation, and lower will the acidic character of that proton. So here, in the among these two, which proton will be more acidic? So the proton which is connected to the carboxylic acid is more acidic than the proton which is connected to the alpha carbon of the carbonyl, right? So here, if this is more acidic, what that means, pKa of this proton will be less than the pKa of this particular hydrogen, because Ka for this OH, for this H plus, is higher than the Ka of this proton. So that is why if you are talking about 2.34 pKa, it will correspond to this carboxylic acid, and 9.6 will be corresponding to this proton. Now, if you have assigned all the values correctly, so now tell me, if the pH is 12, pH is basic, right? So pH, if it is basic, then what happens? it will abstract the most acidic proton first and then the second most acidic proton. But as you can see, the pKa value is approximately 10 for the beta proton, but the pKa value is 2.3 for the carboxylic acid proton. So the pK of 10 and pH 12, the basic medium is not that much basic. The 12 is not that much basic to abstract the proton from a pK of 9.6, but it is well basic to abstract a proton from 2.34 pK, right? So here this concept is very important. So here, if the pH of the solution is 12, then it will abstract a proton which is higher in acidity. Okay. So now which form will predominate, A, B, C, or D? Anyone? Any guesses for this particular problem, guys? Okay. So here, see guys, what happened. So if you have the pH 12, that is basic pH, then it will abstract a proton from this carboxylic acid proton rather than the beta proton, because the pK value for this acidic proton is very low. So it will be very much abstractable by a base in the basic medium, but rather than this pK of 9.6 proton, right? So the proton which is having a pK of 9.6, it is not readily abstractable, but the pK 2.34 proton is very much abstractable in the case of pH of 12. So the basic pH will be able to abstract this proton but will not be able to abstract this proton. The correct option will be option number C, because in C only you will have this COO minus, and this proton is as it is, NH2 is as it is, but all of the if you see this A and D, NH3 is also getting protonated. How NH2 is getting protonated? In the basic medium, why this basic nature NH2 get protonated? In the acidic medium only, this NH2 will get a proton. If the pH is 6 or 4, is 4 or 3, then you can say this NH2 can get protonated. But in the basic pH, it never get protonated. So A and D is not possible because NH2 is getting protonated in the basic medium. So A and D is, although wrong, but when you are comparing B and C, they are suggesting that COH proton is as it is, CH proton is as it is. It cannot be the case because pKa for that COH is very low. So in the basic medium, it is the first proton which is abstractable. So here it will abstract a proton from that center. That is why C will be the correct option. So is it understood? Okay, if it is understood, then I'm going to problem number 10. So it is a very basic question. So they are asking what is the correct IUPAC name of the following. So what will be the correct IUPAC name? See, you have to start the numbering from the highest priority order. So if you see IUPAC rules, then you will see that the aldehyde is getting a priority over nitro and methoxy. So here, if you are starting this numbering from the carbon number 1, carbon number 2, 3, 4, 5, and then 6, right? So why we are not going in this direction? Why we are not numbering in this direction? We can also number now, but here what happens, if you are numbering in this direction, 1, 2, 3, 4, methoxy is at 4, right? But 5 and 6, your nitro will goes from 2 position to 6 position. Now it is not favored. We have studied that the numbering is facile from that position where the substitute is getting the lowest priority, lowest number. That is why we are going in this direction rather than this, because our methoxy is getting 4 all the way from each of the side, but our nitro is getting either 2 or a 6 priority. So 2 priority is favorable rather than 6. That is why we are going from number this side. And now if we have to name it, so we have to name according to the alphabetical sequence. So now this is 4 methoxy and 2 nitro, because here M and N you have to number according to alphabetical order. So 4 methoxy will be written first and then 2 nitro, and the moiety which is there is as the benzaldehyde. So it would be named as 4 methoxy 2 nitro benzaldehyde. So the correct option will be option number A, because it is the 4-methoxy 2 nitrobenzaldehyde. Okay, so is it clear to all of you? It's a very basic question, only the IUPAC name you have to answer. I think it is a very easy question which I have put it in the main PPT. Okay. So now coming to problem number 11. So which one out of the pair A to D is a stronger acid, and explain the reason of your choice. So amongst these pair you have to decide which is more stronger acid. So coming to the problem number, part number A, acetic acid and the chloroacetic acid. So I have prepared these structure. So you have to first figure it out which of these between chloroacetic acid and the acetic acid is more acidic. So now I have told you to suggest the acidity. The carbonyl carbon is has to be more electropositive. So in which case it would be electropositive where the electron density is less. There is a species which is connected which can withdraw electrons, and then you can say the carbonyl carbon is electropositive. Then it will start pushing electrons from this oxygen, and this OH bond will become labile. So when the OH bond become polar, then the H plus is very much readily available for the ionization. So now tell me which is the electronegative atom in chloroacetic acid or acetic acid which is attached. Anyone? Okay. So guys, what happens here? This Cl is electronegative atom, but when you are saying this OH is fixed, okay, only this R group is varying. So here methyl is present and here Cl is present. So chlorine is more electronegative, obviously, but methyl is what? Electron releasing in turn. So here this Cl is attracting the shared pair of electron towards itself because of the electronegative behavior, and so that is why this carbon is becoming more electropositive. So more electropositive means OH is more labile. So OH is more polar. But when you are saying this acetic acid, this methyl group is what? Electron releasing. So if it is electron releasing, it is giving electron towards this carbon. So it is making this carbon less electropositive than chloroacetic acid. So here the correct option will be chloroacetic acid. It is more acidic than acetic acid because of the Cl having the electronegative nature. Okay, is it understood? Okay, if it is understood, then we are going to part number B of this question number 11. So in part number B, they are comparing benzoic acid and the para-nitrobenzoic acid. So benzoic acid and para-nitrobenzoic acid. Guys, see, I have told you you have to see the electropositive of the carbonyl carbon. So higher the electropositivity of the carbonyl carbon, higher will be the probability of that particular OH bond to be labile, and higher is the acidity of the compound. So if you are going to think about these compounds, the nitro is electron withdrawing in nature. It will withdraw electrons from this ring, and also from this position it will withdraw electrons. So it is making this carbonyl carbon more electropositive than in benzoic acid. So it will be more electropositive because of the nitro, that is electron withdrawing, which is withdrawing electron towards itself, and thus it is making this particular species more acidic than benzoic acid. So here in the part 2, we are clear that the para-nitrobenzoic acid is more acidic than the benzoic acid. But when you are coming to part 3, so in the part 3, so the answer for this is chloroacetic acid. Answer for this is para-nitrobenzoic acid. But now you are coming to part number C. So they are comparing phenol and ethanol. So now if you are comparing phenol and ethanol, what will you see? The oxygen ion which is getting generated here will be stabilized or not, right? So is it stabilized? In the case of phenoxide ion, it is stabilized due to the delocalization. It is very important, right? So it is delocalization is there. So that is why it is readily releasing this H. So here phenoxide ion which is getting formed after removal of proton is very much stabilized due to the resonance. That is why this compound phenol is readily releasing a proton. So that is why the phenol will be more acidic than ethanol, because there is no other species which is there to stabilize this oxyanion. Okay, so the correct option will be phenol. Phenol is more acidic than ethanol. Clear this much? Anyone has any question in this regarding any of the part? Anything which is not clear? Okay, if not, then we are going to problem number 12. So now they are asking which class of compound shows hydrogen bonding even more than in the alcohols. So now you have to answer that the class of compounds which is showing more like intense hydrogen bonding than alcohols. Is it phenols? Is it carboxylic acid? Is it ethers? Is it aldehydes? Now one by one, just tell me. Uh, Ether can form hydrogen bonding, but is it intense than alcohols? No. Aldehyde? No. Carboxylic acid and phenol. If you are talking about phenol, see, phenol also have the same kind of hydrogen bonding like alcohol, because there are only one OH group that is present in all of these, one heteroatom that is present. But when you are coming to carboxylic acids, what is the structure of carboxylic acid? So here, this is a carboxylic acid, right? So now if you have this carboxylic acid, then it can also show you this kind of, right? So now tell me, there is a hydrogen bonding which is present between this OH. If I have to write it like this, so I'm writing this OH here, and this hydrogen is getting in the hydrogen bonding with this oxygen. So this kind of hydrogen bonding pairs are present in carboxylic acid, which is not present in phenol, ether, and aldehyde. So here you have two sides for the hydrogen bonding. So it can be intermolecular hydrogen bonding, intramolecular hydrogen bonding, but you have two sides. So at the same time, carboxylic acid are forming two hydrogen bonds, which is not possible in alcohol, because alcohol at a one time is forming only one hydrogen bond, right? So in the case of a carboxylic acid, it is acceptor donor, both things are attached, so that is why they are able to form simultaneously two hydrogen bonds. So here you can say this class of compounds are showing hydrogen bonding even more than in alcohols. So alcohols are showing the hydrogen bonding lesser than carboxylic acid. So the correct answer will be B, because carboxylic acids are the compound that are showing hydrogen bonding level even more than in alcohols. So you can say because of the OH bond in COH is more strongly polarized due to the presence of electron withdrawing carboxylic group. Here, now this OH is bond more polarized, which is very readily showing the hydrogen bonding due to the presence of this carboxy group, because after removal of this proton, this oxygen ion is delocalized with this carbon. That is why it is very readily showing you the hydrogen bonding, stronger hydrogen bonding than alcohols. So is it clear to all of you why it is showing more hydrogen bonding than the alcohols? Why more severe hydrogen bonding, I should say, than alcohols? Okay, so if it is clear, then I am moving towards the problem number 13. So now in the problem number 13, they are asking acetic acid is a weak acid than sulfuric acid because which of the following reasons? So now see guys, acetic acid and sulfuric acid, they are, you have to compare them, but they are already saying that acetic acid is weaker than sulfuric acid. Now you have to fix which could be the possible reason. So the option would be like, option A is it decomposes on increasing temperature, B is it has a less degree of ionization, C is it has a COH group, D is it has a more inductive effect. Option A is getting eliminated because acetic acid doesn't decompose on increasing temperature. So you have to figure it out whether in the B, C, D, which could be the possible reason for acetic acid to behave as a weak acid than sulfuric acid. So now I am showing here the structure of both. This is acetic acid and this is sulfuric acid. So if you see this OH, this acetic acid is having a OH, but sulfuric acid having two OH. So here acetic acid has one ionizable hydrogen, but in the case of sulfuric acid there are two ionizable protons that are present. Is it clear? See what happens. What do you mean by ionizable proton? Ionizable proton means if you are adding this acetic acid and water, if you are dissociating it, then after dissociation you will have one proton in the system, but when you are adding water and sulfuric acid, you will have two dissociated protons in the system. So the ionization of the sulfuric acid is higher than acetic acid because of the presence of higher number of ionizable proton in the sulfuric acid. So, see, I'm repeating myself again because it is a bit confusing. So what is happening here in the acetic acid case? You have one OH, one proton that is ionizable, that will dissociate when you add this acetic acid and water, and it will form one H plus acetate. Okay, but if in the case of sulfuric acid, what happens? Sulfuric acids are two ionizable protons. So if you add it in the water, what happens? It will release two protons at a time. That is why the degree of ionization for this H2SO4 is higher than acetic acid. So coming back to the question, they are asking in the option the reason of the weak acidity is it has a COH group. No, it is not the case. Inductive effect not playing any role. Here is the less degree of ionization because acetic acid has a low degree of ionization than sulfuric acid because of the presence of less ionizable proton. So the correct option will be option number B, because ionizable proton in acetic acid is lower than an ionizable proton that are present in sulfuric acid. So is it clear to all of you why it is weak? Because of less degree of ionization. Right? Okay, if it is clear, then I'm going to problem number 14. In problem number 14, they are asking in acetic acid and formic acid. Formic acid, which will be which of the following? Less acidic, equally acidic, more acidic, and not say about the acidic behavior. Actually, D is eliminated all the way because we can say about the acidic behavior, right? So they are asking, is the formic acid more acidic, equal acidic, or less acidic than acetic acid? So here, if you see formic acid, this having the same kind of structure, but here this there is H and there is OH. So this is what formic acid look like, and this is what acetic acid look like. So if you are saying that it is higher acidic, why? See guys, I've told you many a times that the electropositivity of this carbon matters. Now the OH is fixed, but the R group here is H and the R group here is methyl. So what happens is methyl is an electron releasing group. It will give the electron towards this carbon. That is why making this carbon less electropositive. So electropositivity of this carbon is getting decreased. So that is why if you move towards this formic acid, in the case of formic acid, H is not electron releasing. So the electropositivity of carbonyl carbon is higher in the case of formic acid rather than the acetic acid, because methyl is electron releasing and it is also releasing electron towards the carbonyl carbon, which is making carbonyl carbon less electropositive. That is why we can say acetic acid is higher in acidity than, sorry, formic acid is higher in acidity than acetic acid because of the electron releasing group that is present in acetic acid, but here hydrogen is not playing as an electron releasing group, so it is not in decreasing the electropositivity of carbonyl carbon. So what we can say is the formic acid will be more acidic than acetic acid. Why? Because of the presence of electron releasing group in the acetic acid, it is playing a role and thus decreasing the electropositivity of the carbonyl carbon in acetic acid. Fine. So is it clear why it is more acidic? See, there is one thing that is plus I effect of methyl, and the next thing is lesser is the stabilization of conjugate base. So you have to see also that thing. Conjugate base means after removal of the proton, this oxygen ion is getting formed in both the cases. this oxyanion. Now this oxyanion is stabilized by methyl or hydrogen. Which group can stabilize it? Hydrogen. Why? Because methyl is electron releasing, right? So plus I effect is there. It will also it will destabilize the negative charge, but H is not like that, so it will stabilize that negative charge more. So here also you can say, according to this point, we can say that formic acid is more acidic. Fine. So just give it a look. If it is not understood, then just tell me. I will explain again in the next class. Okay. So now coming to problem number 15. Guys, they are asking which combination of carbonyl compounds give phenyl vinyl ketone by an aldol condensation. So now I hope all of you understand what is an aldol condensation. If not, then I will give you a gist. What is it? So here they are asking which combination will give you this compound as a product. So in the aldol condensation, the H2O release takes place. So this alkene bond which is getting formed is basically like this OH and H. Here is H. So after removal of water molecule, this particular phenyl vinyl ketone is getting generated. But here they are asking which combination is favorable. So if you are considering this acetophenone and benzaldehyde and aldehyde, see, aldol condensation to takes place, one of the species, one of the starting material must have a alpha hydrogen present in the system. One of the species must have an alpha hydrogen present in the system. So if you are uh, thinking about this benzaldehyde and ketone, sorry, aldehyde doesn't have alpha hydrogen. Again, benzaldehyde is what? Benzaldehyde is this. You have, instead of methyl, you have this hydrogen. This is the benzaldehyde. So benzaldehyde also doesn't have any alpha proton which is present. So C option is also getting eliminated. If you are having three option in hand, now see one by one. Acetophenone ketone, acetophenone aldehyde. What is the acetophenone? Acetophenone is COCH3 with a benzene ring. If we have a R group instead of H, this will be ketone, and if it is HH, then it will be aldehyde. So first we will go through aldehyde. So in the aldol condensation, the base will abstract a proton from the alpha position of the carbonyl carbon. So here this alpha hydrogen is present on the acetophenone, so it will get abstracted to form this anion. This anion will then attack on the aldehyde, and this oxyanion get formed. This oxyanion is taken up a proton, and after that the condensation takes place. That I have told you, the water molecule will leave to give you this. So this is what we are finding phenyl vinyl ketone. So when we are using this acetophenone with aldehyde, we are getting that particular phenyl vinyl ketone. But suppose if we are starting with benzaldehyde and this ketone, what happened? Instead of H, we have a R here. Sorry. We have a R here. So instead of H, we have a R here. So if we have a R, so also at this position you doesn't have a hydrogen, it will be R. And also at this position, some of the substitution is there. If you are considering aldehyde instead of, sorry, if you are considering ketone instead of aldehyde. So in the particular product, you must have this R group present with you if you are starting with acetophenone and ketone. That is why A is getting eliminated again. So B is the correct form which is giving you the required product. So that is why the correct option will be option number B, because if you are using this acetophenone with aldehyde, you will end up having phenyl vinyl ketone in hand. Right? So is it understood, guys? Okay, if it is understood, I am going to problem number 16. So here they are asking sulfonation of benzoic acid produces mainly which of the following? So sulfonation of benzoic acid, right? So now just remember, just recall once what is the electrophilic substitution reaction. So if we are talking about the electrophilic substitution reaction, it will goes towards the meta position for electron withdrawing group. But in the case of electron donating group, what happens in the case of amine electron donating groups? It is going towards ortho and para selectivity. So if you have in a system where amine is present, then you can say the electron releasing group is there. So now ortho para selectivity comes into play. But if you have electron withdrawing groups like acetic acid, benzoic, like acids, nitro, cyano, which is electron withdrawing groups, then you can say the meta directors are playing the role. So the meta form is predominate at that system. So here, if nitro, like electron withdrawing, is present, electrophile will stabilize the meta position well rather than ortho and para, because an unstable positive charge is getting formed in both the cases of ortho and para. So it is actually a 12th standard question. So here the correct option will be option number B. Why? Because sulfonation of benzoic acid means benzoic acid is also electron withdrawing group. So if it is an electron withdrawing group, it will direct the electrophilic substitution reaction at the meta position because of the extra stabilization of the electrophile. That is why we are saying that the option number B is the correct one. So the meta sulfobenzoic acid is present, is forming predominantly in the system. So is it clear to all of you? Problem number 16 is very quite easy question. So I hope it is clear. Okay, so if it is clear, then I am moving towards problem number 17. So guys, they are asking what will be the reactivity order of the following with water. See, you have water and you have to assign reactivity order for these kind of halides. See, all of them have the carbonyl group present. Acid halide, ester, acid anhydride, acid amide. So all of them have a carbonyl group. So you have to assign the reactivity order with for the water molecule. Water molecule is what? A nucleophile. Because in the water molecule, this H2O, this oxygen has a lone pair of electron, and it will be acting as a nucleophile for your carbonyl group. So now the better electrophilic center will be having a higher reactivity towards this water. Is it understood? See, higher the probability of electropositivity in the carbon, higher is the reactivity order for water, because nucleophile will attack at that position which is more electrophilic, right? So here, one by one, we will see the electrophilic character of this carbonyl group. So here, coming to this acid halide, chlorine, although electronegative, it will abstracting the proton towards itself. That is why it is making this carbonyl carbon way more electrophilic. So here, methyl is constant. See, methyl is constant. One of the methyl is constant for all the species. All of these contains one of the methyl. So now you have to see another substituent that is present. So Cl is all the way electron withdrawing, it with taking the electron towards itself, and here electropositivity will increase of the carbonyl carbon. But when you are going to this acid anhydride, what happens is oxygen, lone pair are there, so it is more donating towards this carbonyl carbon. Same donation can happen to this side as well, right? But there is a competition between the donation of oxygen. If you are comparing this anhydride and ester, both of the cases having the oxygen as the donor atom for the delocalization, right? But there is a competition between there is a competition in acid anhydride to donate the lone pair of oxygen to one of the carbonyl. So here at a time, oxygen will be delivering the electron density to one carbonyl only. At a time, one carbonyl is getting a higher electronegativity than another carbonyl. So one carbonyl is always electropositive than another carbonyl, right? So this is how you have to see it. There is, if the 100%, if it is 100%, see, if it is 100%, if I'm saying the 100% donation is taking place, then there is 50% donation which is present to this particular carbonyl, and 50% donation which is present for this particular carbonyl. There is a competition. But here, if you see, whole 100% donation is going to one carbonyl only. So there is a partial double bond which is getting created between CO. That is why this carbon is way more, like less electropositive when you are comparing it with acid anhydride, because the carbonyl is getting only 50% of electron density of this oxygen. That is why it is higher in electropositivity than ester. Now, if you come to this amide, this nitrogen, so as we know, fluorine, oxygen, and nitrogen, fluorine is more negative, electronegative than oxygen, which in turn is more electronegative than nitrogen. Nitrogen has a donor ability greater than oxygen. Why? Because oxygen is more electronegative. It is less donating than nitrogen. That is why here it will be highly donating than oxygen. So that is why we are having a partial double bond character between the C and bond. So that is why the amide, because of the higher donation than oxygen, amide will be the least reactive. Why? Because now the electropositivity is way less than these particular three compounds. So it is least. So the electropositivity of this carbon is very low. So here I have compared these two. So in these two, the electropositivity of this anhydride is higher than ester. So that is why it is higher. The reactivity is higher. And anhydride, this acid halide, is highest reactive for this water molecule because of the highest electropositive character present for this carbonyl carbon. So this is the correct answer. This will be the correct order. So the correct order will be acid halide, anhydride, anhydride, ester, and amide. So the option number D will be the correct one, right? So is it clear to all of you why it is the right option? I hope it is clear now. If not, please ask me once. Okay. So if it is clear, I'm going to problem number 18. Now, coming to problem number 18, they are asking which of the following is most reactive. As I have told you guys previously, also we have seen the reactivity order of these kind of organic compounds only. So here, this acid anhydride is there, acid ester is there, amide is there. I've told you donation ability of this nitrogen is higher than oxygen because of the low electronegativity, and you are asking about the most reactive. Most reactive towards an nucleophile. So here the most reactive compound towards the nucleophile will be compound number 1. Why? Because it is having a electropositive character very much, because here the CF3 is also getting attached now. So electronegativity of this CF3, electron withdrawing group of the CF3, electron withdrawing nature of this CF3 making this carbonyl carbon more electropositive. So that is why the correct option will be option number 1, because this anhydride is now highest in reactivity. So is it clear to all of you now? I have actually explained the similar thing on this particular question. That is why I am just relating this particular question there. So here, this acid anhydride is most reactive towards a nucleophile. Is it clear to all of you? Have all of you understood the problem, understood the answer? Any query, any doubt, please ask me. Okay, so if not, I'm going to problem number 19. So here you have to assign the decreasing order of basicity. This will be the last question of this session, guys. Uh, please have some attention here. So they are asking decreasing order of basicity of the given compound is which of the following? So decreasing order of basicity now you have to add. So now I have just drawn these three as these three. This is 1, 2, and 3. So now you have to assign the decreasing order of basicity. Nitrogen having the lone pair, nitrogen again having the lone pair, nitrogen having the lone pair. So decreasing order of basicity. Now here, just tell me, is there any other delocalization or something which is present in this particular compound? No. So it is the highest basicity compound. Why? Because now you can see here this nitrogen lone pair is in the conjugation. In the conjugation with this 1 and 3, similar kind of scenario is there. It is in the conjugation with this carbonyl compound. So that is why it is making this NH2 lone pair less readily available for the electrophile. So here amine second will be highest in basicity. Now you have to look at first and third, which would be higher basic. So now comparing these two will give you the another set of answer. So now this for sure is the highest basicity. Now you in the 1 and 3 you have to compare. So if comparing 1 and 2, the second group which is attached here is the methyl. Second group which is attached here is the phenyl. So this phenyl group has a minus I effect. So it is actually taking electron density towards itself. So now if it is taking electron density, then it is making this carbonyl carbon electropositive. So now electropositive carbonyl carbon will abstract, will try to pull electrons towards this towards itself from this nitrogen, and that is why the donation will be higher, and that is why the CN bond will get shorter, and this amine will be way less basic, because here methyl group is attached, it is electron releasing. Now methyl is releasing the electrons, making this carbonyl carbon less electropositive, and thus this donation of NH2 is generally, because of delocalization, the NH2 is dealing with this crisis. But here another factor is there in the case of 3. What happens? Phenyl having the minus I effect, it is also abstracting the electron density towards itself, and that is why this third particular compound is getting what, lower in basicity. So now this amine donation is higher than in the case of first. So third is less basic than second. So the order will be 2, 1 and 3. So the correct option will be option number B, 2, 1 and 3. So is it understood, guys, why the basicity order is this only? Why the third is less basic than first? Is it understood to all of you? Okay, if it is understood, I hope it is a very beneficial session for all of you. And thank you so much for attending the session. I'm just closing the lecture only. So here we will meet you again. Like we will meet again on next Saturday, 6 to 8. So please be tuned. And I'm uploading this session on the YouTube channel. If you have any query, any problem regarding this, so just text to the chat box, or you can ask me in the next session as well. Okay, so whichever you like, whichever way you like, you can go through that. Okay, so guys, I'm closing the session. Thank you so much for patiently listening me. It is very good time to have. So thank you so much. So I am closing the session.